Hello everyone, welcome to Reactify Labs. Today we will talk about another behavioral design pattern called Iterator design pattern. So let me write it down first. Iterator pattern. Okay. So what is iterator pattern? Iterator is a behavioral design pattern that lets us traverse elements of a collection without exposing its underlying representation. So I'm not sure if this definition cleared anything, but it's something which we have already used, but we don't know it. Probably we don't know, probably we know, but it's a common thing. In Java, we have something called enhanced for loop. So let's say if we have a string of, if we have an array of strings or a collection of strings. So what we do is we write something like for string and let's say the collection of names. So we write for string name in names. This names is basically an array list of strings, and we will just print this name. So this internally uses iterator pattern. Okay. Similarly, in C++, we have something called, let's say if we have a vector, so we just write like for auto it vector. If we have a vector of string and its name is names, so we just write it like this and we just print cout it and it just prints the names, right? So this is the um, use case where this iterator pattern is used. And why we are using it is because, let's say if we just write sorry, I'll just bring it back. Okay, so if we write these things in both Java and C++, Java and C++, see, we do not need to know what this names is. Even if it is stack or queue or a tree or a map, it works fine. Similarly in C++ also, if it's stack, queue, map, set, tree, this works fine, right? So we do not need to know the underlying representation of the data structure. This iterator pattern does that for us. It will, whatever the data structure is, it will do the traversal for us. Okay, we do not need to know. So it's very good at hiding the actual implementation and only providing what is needed. The user only needs to know what are the elements in the particular data structure. That person does not need to know how that is implemented or what kind of data structure is there. So in that case, this iterator pattern is very helpful. So I'll create from scratch this design, how this is implemented. Before that, in Java there is something called iterable. There's an interface called iterable, and if some class implements this iterable interface, then an iterator pattern is just provided and that person can use it. Anybody can use that, that class can use it. Okay, instead what I'm going to do is I'm not going to use the iterable library, iterable interface. Instead I'll just show how it's created. Okay, so we will create an interface first. So we'll have an interface called iterator, and it has two things. Okay, when we do that for loop thing, it internally checks two things. One is a function called has next. So for any iterator, it will check if the next thing is available. If the next thing is available, then it will use the next function to get that. Okay, that's it. That's the job of the iterator. Iterable is also implemented like this. Okay, and there will have one more container, one more interface called container. Okay, and this container will have nothing. It will just have a function called get iterator. So this container, whatever the container is, the container can be an array, the container can be a list, the container can be a set, the container can be a map. This will just give the particular iterator, the iterator of that particular data structure. Okay, that's it. Now, let's say we have a list of names which we need to iterate. Okay, so we will have a class called name iterator. Class name iterator, which implements this. Okay, so this class will have a string of names. string of names will be there, and there will be an index. Okay, this will have a constructor, obviously. Name iterator will have a constructor with names, and all we are going to do is just assign, as you know what we do with constructor, this dot names equal to names. That's it. Okay, next is, we know this is the interface and it has these things, so each of the class which implements the interface has to override the methods which are there in the interface. Okay, so it will have this like has next. And what this has next does, this has next checks if the next element is there or not. Let's say if we have a list of names like Rock, Brock, Sean, Lawn. Okay, so it will check, okay, if the next is, the iterator is currently here, it will check if the next exists. Yes, it will go and fetch it. If it is here, it will check, okay, has next returns false here, means there is nothing next to it, so it will not do anything. Okay, so has next does the same thing, it returns a boolean. So if you see, we have an index here, so this index is currently at 0. Okay, and it will check for has next, it will check if this is less than index is less than names dot length, because we have names. So only if the index is less than names dot length, only then it will return true, otherwise it will return false. That's it. Has next is this simple, because it's, you already know this, you have used this concept before, right? So if the index is 0, okay, it knows, so it has to get this, it has to get 1, 2, 3. If the index is already here, it knows that the size is already 4. 4 means the last index would be 3. For 4, the last index is already 3, and so nothing else is there, and has next will return false. And if has next is there, then we have to get a next element, right? So for getting the next, before getting the next, if we just call the next here, it will give us a null pointer exception because nothing exists. So instead of directly calling this get next, what we will do is we will check if has next is true, right? If has next is true, then we will return names. We have an array of names, and whichever place the current index is, and we will increase the index. That's it. That's it. That's the implementation of next, and this is the implementation of has next. Okay, got it? And we have a name repository. Okay, this is the iterator where we have done all these things, and now we have a repository where actual names are there which we are iterating. So this is a container extension. So this name repository, name repo, this name repo class will implement this container, means any container can be there. This container can be tree, set, map, anything, right? So this will have a string of names, and it will have all the names, right? And it will have a function called get iterator. Get iterator, we have to get the iterator from here, name repo. Why? Because in this name, only when we come to this name repo, we will realize what kind of data structure is there. We means the people not who are using it, who are creating this. Okay, so we have to this get iterator here, and we will return new name iterator with this names. So if you see, this constructor is called to create the object. When this iterator is called, this iterator will give us an object of this constructor. Okay, and once this is all done, all we have to do is see how the client code is going to use it. So the client code, what it does is, it has a name repo space name repo, because we have to iterate over name repo, right? Equal to new name repo. Okay, once it is done, what we have to do is, we have to check, we have to make an iterator. So this iterator will be what? Iterator iter equal to, this iterator will come from this name repo dot get iterator. If you remember here, this get iterator, this will return an iterator to us. Okay, when iterator is called, what kind of iterator will it return? Depending on the kind of data we have. Now we have string of names, so that kind of iterator it will return. And for printing, we have to just check while iter dot has next. So it will check if this iter has next. If the next element exists, so it will print what? It will print iter dot next, and that's it. As long as this iter dot has next is true, this will print iter dot next. And if you see this implementation, when iter dot next is called, this index automatically increases. So we do not need to explicitly do anything else to increase this index. So next time when this while loop is called with iter dot has next, the index is already pointing to the next element because this next has already incremented it. So this goes behind the scenes. Behind the scenes, this has next and next is called when we just do a for loop, enhanced for loop. Okay, in both Java and C++. So this is it. I hope this is clear. Just let me reiterate it one more time. This iterator, I'll clean it. This iterator object is created. Okay, this iterator object got created from here, this line. Okay, once this iterator object is created, what has happened was it has checked iter dot has next. This iterator object, if you see this get iterator, it's a new name iterator. So name iterator for this class, and this class has functions called has next, and this class has function called next. So for this next and has next, it will do nothing and it will just print it. So has next, it checks for the next element's presence. If it exists, it will print. If it exists, it will print. If it exists, it will print. Okay, and once it is false, like the has next returns false, it means the while loop terminates and the loop will get over, and iteration ends. So that's it. I hope this clears the iterator design pattern. This is not something new. I just showed you the internal implementation. You don't need to know it, but it's good to know how underlying things work. And that's it. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.